Hello everyone. Let's continue talking about collections. We talked about a single linked list last time. We actually realized it from scratch. It was actually a data structure that consists of nodes. Each node has info and a link to the next node. And the last node actually links to null, so to nothing. And a variable has to be pointing to the head of the list of a single single linked list, because otherwise it will be forgotten. There will be no way to reference it. So feel free to check out the previous lecture. We did a reverse there and like add to the beginning and to the end, and it's very similar to the magazine project. They did not do reverse there, and it's similar to what you need to do in the in your homework. In your homework, you need to either insert something or delete something to the linked list. All right. So there is something called doubly linked list, that is where each node has two links, one going to the next and the other going to the previous. And of course, for the head one, the previous is null, and for the last one, the next is null. This is easier because now we can go in both directions as opposite to a single linked list. Once we moved over there, we have no way of returning to the middle. Once we move to the right, there is no way to return back to the middle, and we have to use this list variable to start in the head again and go there. But with a two-sided doubly linked list, we can go left or right, next or previous, from any point. There is a representation when the head is kind of header node is special. It contains the length and also front and rear, and at times that is very convenient. For example, for a Deque. Deque is something that is actually realized in Java. And let us look at some basic data structures. Queue. First in, first out. So it's a sequence or a collection where you are allowed to add to the rear, that is in queue, and you are allowed to remove from the front, that is deque. And together with that, you are allowed to check if it is empty, like in queue, deque, and check if it is empty. Maybe some realizations have some other methods for the queue. And kind of in case you need to order something that is backed up while waiting. And the basic idea of queuing people or queuing things, just that's what it is for. Okay, there is another data structure, first, like last in, first out, in other words, a stack. So you can push something into the stack, you can remove something, pop something from the stack, you can pick at the top of the stack, and you can check if the stack is empty. And that is the whole functionality of it. And of course, the advantage of such data structures, they are very, very simple, and hence they are very fast. Okay, let's skip the examples and look at something more sophisticated. A tree. A tree has a root. Like, think of this as an upside down tree. The tree has a root, and then it's branching onto other nodes, but once you branched out in a certain path, you cannot go back to the root unless you are directly going backwards. So there is no way to go from here to another node that you did not meet yet. By the way, this kind of there is like a parent-child relationship here. So this is a parent, it has 4 children, so nodes directly connected on to the previous node, and then this parent has 3 children, and this parent has 2 children. Now, childless nodes are called leaves, like leaves on the tree. If you flip this picture up, this is like an upside down tree. So these 2 are leaves, and so is this one. More general than the trees are graphs. Graphs are allowed to have a cycle. Like you can go in this cycle forever, walk around this path forever. And besides simple graphs with non-oriented edges, there is oriented graph where like edges have a direction, D-graph, directed graph. You are allowed only to move only according to the arrows, and here you can go both ways, or you can go in. This is a directed cycle, but you cannot reverse. This is the only way how you can cycle through this node. And before we create something interesting like a tree, that is probably in the next video, I'd like to play a little bit with the Java collections realizations. Let's look at this scheme and close the add. So at Java point, there is basically a map of collections. What does collection have? So collection inherits from iterable. There is a list, queue, and set. Priority queue is implemented, and also Deque. Deque means a two-sided queue. So it's a queue where you can, let me save as tree and create a new thing here. So, okay. We have, first of all, it's a linked list with some additional features. So Deque or Deque, and that's how it's spelled. It is a double queue, so we can add here, like add first, or remove first, and similarly we can add last and remove last. And like this will be like the first variable. It's convenient to point over here because we will need it to add and first, and so is pointing over here current last. And of course each node has next and info, the useful part. So this is a two-sided, like a double access queue. You can add to the first, you can remove the first, or you can, this is actually the last. If, yeah, okay. And info and next and so on. And this goes to now. So this is the idea of a deque. You can only add in the beginning or you can add in the end, and every node has info and the next. So you cannot insert in the middle. That's just not something that the Deque will allow. Okay, so this is what we are going to look at in more detail, just for the sake of it. And let me find it in here. So blue is interface and green is actual class. So we can create an array deque, an array Deque, properly pronounced array Deque. and let's see what it has. So open the Java documentation, or actually Java point if you'd rather open that, and see what we're able to do here. So add first, remove first, and examine get first. That is just looking at it without removing it. So let me go ahead and create a little Deque. So this is array Deque. This will be array Deque of integer, and we will call it Deque new array. Alright, and then we will have Deque dot add first, for example, 5, then Deque again add first 7, and think what I'm doing when I'm adding in this order. And finally I'll add last 3, and then finally I want to print it. Oh, sorry, I'm Pythoning it. System.out.println Deque. So let's see what will this do. So this adds first to the empty Deque, then it adds first. So think where this will go. So 7 will be in front of 5, and then we add 3 in the end. So that's what we are expecting to see. And while it's running, I will remove first, or seven, 5, 3 as promised. 7 is actually first because it was added first later than 5. And alright, let's see. Get last and get first. So all the methods that we have. Let's do get last and print it. So the last one was 3, we got that, but it's still on the Deque because we did not remove it. And we can look back how to we actually remove it. So remove first, okay. Let's do remove first now. So pretty much copy paste the same thing. Remove last, and now check the Deque again. So now we should actually remove the last one. Alright, so that is the Deque data structure in a nutshell.